My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 440. In this lecture, I will continue my discussion on image histograms. In my previous lecture, that is in lecture number 439, we discussed about first type of image histogram, that is color histogram. In this lecture, we will try to understand second type of histograms are called edge histograms. We see what is edge histogram. We will see what is edge histogram. Edge histogram is a very interesting idea. If you take an imagine there is an image, and when you have an image, let's assume this image looks like this. What are the edges here? This one is edge, even this one is also edge. These are called edges because there is a boundary between one region and other region. There are a lot of algorithm to detect where is an edge in an image in image processing. So in the area of image processing, there are lots of algorithms to detect where is an edge in an image. Once if you detect there is an edge here, once if you detect there is an edge, let me say like this. Yes, once if you detect there is an edge, let me show like this. Otherwise just check this one. What is an edge? Basically what is an edge? There is a different color. Just see, there is a different here there is a different color. Here if you observe, here you have different color. Just let me say, here you will have different color, here you will have different color, isn't it? There is a different color here, and there is a different color here also. In that case, this particular thing, this will be called as an edge. So once if you have an edge, suppose let me say like this. Suppose if you have an edge like this, in first case, just let me show this one. If you have an edge like this, what it is called horizontal edge, isn't it? You can give a value of 0 degree. For this one, which value one can give? 0 degree. You can say this is also edge. The edge has, what is the value of this edge? 45 degrees. Similarly, if you have edge like this, what value one can give? 90 degrees, isn't it? You can say edge like this. For example, if you have edge like this, how much, what is the value one can give? 135 degrees, isn't it? While an edge like this, you can have for this particular edge, you can give value 135 degrees. You can break, let me take an image. Just let me, if you take this particular image, just break this region. Just break. What will you do here? You can break whole thing into regions. This is one region, this is another region, this is another region. You can break whole thing into regions, into small regions. Is there any 0 degree edge? After breaking into regions, you have to check, is there 0 degree edge? Is there 45 degree edge? You have to check. After breaking into region, in that region you have to check, is there 0 degree edge, 45 degrees edge, is there an edge of 90 degrees edge, is there any 135 degree edge? You may have some data like this also. Just see, you may have some data like this in this region. What is the angle? You can assume it is 20 degrees, isn't it? Edge has 20. So what you can do is, for every region, let me say like this. For every region, we can say, in this particular region, just let me show this one. For example, this one, what is this? This is in this region. This is just like 45 degrees, isn't it? This is also 45 degrees. In this region, what about this edge? 135 degrees. Just something like this, 135 degrees. In this case, this one is similar to this 90 degrees, isn't it? Again here, this one in this region, that is 135 degrees, like this, isn't it? Let me say this one, this region here, it is similar to this one. This is just 0 degrees. What about this? This is just similar to 135 degrees. Isn't it? What you can do here is you break up your big image into grid. You have to break up this big image into grid. Then you ask your question in each of these grids. If there is edge in each of these regions, if there is an edge like this, if there is an edge, what is the angle of the edge? That angle of the edge, is it 20 degrees, 40 degrees? It might be case that there may be no edge. For example, here no edge. It might be case there may be no edge. When there is no edge, what value one can give? One can give -1 value. Just see, if there is no edge, give -1. For each of these regions, I will get an edge value. Sometimes I may have multiple edges in single region or in single grid. In such case, I will take more dominant edge. What is this more dominant edge? For example, here I have two edges. This is one edge, this is another edge, isn't it? In such cases, I will take more dominant edge, most powerful edge. For example, suppose I have edge like this. This is edge. Suppose I have edge like this, and I have an edge like this also, a small edge. Let me say a small edge. This is one edge, this is small edge, isn't it? I have two edges, isn't it? Which one is larger? This one is larger. This is dominating edge. I will get, what is the degree for this particular one? 45 degrees, isn't it? I will give value of 45 degrees instead of 90 degrees. Of course, this edge is small edge. It is making 90 degrees. Therefore, which one is? This one is larger one, bigger one, which is making 45 degrees. Therefore, I will give value of 45 degrees instead of 90 degrees because this edge is dominating edge. Isn't it? For each region, I will get edge value, isn't it? Or I can say edge angle. I can plot the histogram of these edge values. Let's assume I try to plot the histogram of edge values, isn't it? Can I plot histogram of histogram? I can plot like this, isn't it? I can plot histogram of edge values, isn't it? And let's assume I try to plot the histogram. Just let me assume this is my histogram. Histogram looks like this, isn't it? I could have -1 value. Just see here. I could have -1 value wherever there is no edge, and let's say 0 to 180 degrees, 0 degrees to 180 degrees. It might so happen that I have the data might look like this, isn't it? Once I got histogram, I can convert into a vector, just the way we did we did it for color histograms. When I construct a vector, one value is -1, one value is -1, just one value is 0 degree, one value is 1 degree, one value is 2 degree. Similarly, one value is 180 degrees, isn't it? I got a vector whose size is 181, which represents edges like just say which represents these edges, isn't it? Edge information or angles. For example, faces that you have a face, your edge histogram is like this, where you have some dominant value. For example, this one you can have something like here your faces maybe after representing. This is your color histogram. Each region you have edge value or edge angle. From edge angle we converted this one into histogram. From this histogram, we know how to construct a vector, isn't it? For example, what it says, faces that you have a face. Your edge histogram is like this. This is your edge histogram is like this, where you have some dominant values. Some dominant values here. Let me say this one is this is some dominant value, isn't it? You have some dominant value somewhere here also you have some dominant value, isn't it? You have some value small here, that there may be value small here, isn't it? This representation, after constructing histogram, how to convert into vector, we already discussed in our previous lecture. You can represent that faces can occur in images like this. For faces, it is not best application. If you speak strictly, this is not best application for faces. This is not best featureization for faces. There is slightly more complex featureization to detect faces called Haar features, isn't it? This is Haar features, which I will discuss in my next lecture, isn't it? Haar features, which are fairly advanced image processing featureization. For now, edge histogram works for some cases. We have seen color histograms and edge histograms, which is very basic. I can say this color histograms and edge histograms are very basic and basic techniques for featureization of images. We will see slightly complex one. We will see state of the art. We will see the state of the art or complex one in my next lecture. We will learn SIFT images, isn't it? We will learn this one in my next lecture. This is SIFT, SIFT, SIFT features, which are very popular for object recognition in my next lecture. As I told you earlier, there is something called CNN, convolutional. There is something like CNN, which is a technique for deep learning, which featureizes images. CNN is almost is the state of the art. Please don't think these are the color histogram, edge histogram only featureizations available for images. There is almost like 30 plus years of research on how to featureizing images for various tasks. I will continue my discussion in my next lecture. In that particular lecture, I will start discussing SIFT images. Just go through it. If you have any difficulty, please keep a comment. Thank you very much.